Okay, good evening, everybody. So, can start the uh, third lecture. So, we'll just continue the design of single reinforce considering or using working stress design. Okay. Okay, so last time, we designed a single reinforced beam. Okay. So, we come up with a beam with a dimension 250 millimeter 250 millimeter by 600 millimeter. And also, we solved or we determined the number of bars to be 4, okay, 4 diameter 25 millimeter. Okay. So from this design, let's try to determine the capacity considering the crack section and considering the mathematical equation using the internal couple or internal capacity or couple from the steel and concrete. Okay. So in the investigation, so in this problem, we have already the dimension. So the dimension is 250 by 600. Then we have here 4 25 millimeter diameter bars. So the effective depth, okay, from the previous example, we have a 552.5. Okay, so 552.5. So first, in determining for the moment capacity, of course, the moment capacity considering concrete, okay, we have from this formula. Okay, so the moment capacity considering concrete, okay, is equal to MC 1/2 FC okay, balikan natin. Okay, so from this formula, so if we factor out M is just simply equal to okay, 1/2 FC times BD squared KJ. So this is the moment capacity considering concrete. And considering steel, from this equation, the moment capacity considering steel is equal to AS FS times JD. Okay, so going back to the section, moment capacity of concrete is 1/2 FC BD squared KJ. Okay, so we have F prime C, which is equal to 21 megapascal. So FC, or the allowable strength of concrete, is 0.45 F prime C. Then B is 250 millimeter. Then D is 552.5 millimeter. Then K and J. So for investigation, K, so the reinforcement and section is given. So considering investigation, the K values is this one. K is equal to square root of 2 n rho or rho n plus rho n squared minus rho n. Okay. So 2 rho n plus rho n squared square root minus rho n. But what is rho? Rho is equal to the steel ratio. So it is the ratio of steel with reference to the concrete section B and effective depth. So AS over BD. So AS is 25 millimeters. So the area of 25 millimeter, okay, 4 times pi over 4 times 25 squared divided by BD, which is equal to 250 times 552.5. So this will give a raw value of, okay, can you compute? 0.0142. Okay. So we have now the value of rho. What else do we need? So the value of n. So n is just simply the modular ratio or the ratio of modulus plasticity of steel divided by modulus plasticity of concrete. So the modulus of elasticity of steel is constant to be 200 gigapascal or 200 times 10 to the 3 Newton per millimeter squared divided by EC. So for normal weight concrete, EC is just simply 4,700 square root of F prime C. So from here, the value of N is equal to 200 to the 3 divided by 4,700 square root of 21. So the value of N is 9.286, or let's say N is equal to 9. So from the code, from the NSCP, N should be the whole number. So just get the whole number. Okay. So knowing for the value of rho NN, we can now solve for K. So K is 2 times 0.0142 times n of 9 plus n or rho of 0.0142 times n of 9 squared, square root, minus n rho, 9 times 0.0142. So this will give a value of K .394. So knowing for the value of K, we can now solve for J. So J is just simply equal to 1 minus K over 3, or this will give a value of J of 0.869. So we have now the value of K to be 0.394 and then J of 0.869. So from here, we can now solve for the value of MC, or the moment capacity considering quantity. So MC will now become 1/2 times FC. So FC is 0.45 of F prime C times B of 250 times D of 552.5 squared times K 0.394, J of 0.869. So MC is equal to, please solve for the value of MC. So what is MC? So same true with the moment capacity of steel. So MS is equal to AS FS times JD. So we have AS, we have FS, we have JND. So this will give the area of 4 25 millimeter diameter bars. So 4 times pi over 4 times 25 squared times Fs. So for grade 40 or Fy of 276 megapascal, Fs is equal to 140 megapascal. So 140 times J. So J is 0.869 and D of 552.5 millimeter. So this will give MS of, okay. So what is MS? So can you solve for MS? Anybody? Okay, so for MC, so 123.46. Okay. MS is 123. MC pala. MC is 123.46. 46 kilonewton meter. How about MS? Moment capacity considering steel. So the moment capacity considering steel is 131 or 132. Okay, 131.98 kilonewton meter. Okay, thank you for the answer, Richard, Adriana, Howard, Crisel, and Paz. Okay, thank you. So from that, the moment capacity of the beam is equal to the minimum between MS and MC. So the moment capacity is 123.46 kilonewton meter. So ito yung base sa derived formula which comes from the cross-section properties. Okay? So how about if we solve the problem considering the internal couple? So considering the internal couple, okay. So considering the internal couple, so we have the stress diagram like this one. So this is FC, this is KD, which is equal to, so KD is 0.394, times D of 552.5. So KD is 217.685 millimeter. So 217.685. And then we have here AS, FS, or just simply T is equal to AS, FS, okay? Then the compression is equal to 1/2 FC. So the area of this triangle so 1/2 times FC times KD times B. Okay? So the lever arm is just simply equal to D minus KD over 3. Okay? Or just simply J times D. Okay. So if we take moment about the steel section, so the internal moment produced by the concrete, MC, is equal to the force, the compression force, C times JD, which is equal to 1/2 FC. FC is 0.45 times F prime C, 21 megapascal, times K of 0.394, okay, times D. D is 552.5 times B of 250 times JD. So J is 0.869 times D of 552.5 millimeter. So ilan yung value niya? So dapat parehas lang yung lalabas na value. Okay? Then considering steel, MS is equal to AS FS times JD. So this will give area of the 25 millimeter diameter bars na 4 times 25 squared times 140 times J of 0.869 times D of 552.5. Okay? So dapat yung result niya is same lang dun sa previously computed values ng MS saka MC. So meaning, kaya ko ginawa yan, hindi nyo kailangang i-memorize yung formula, this formula, and this formula. So you can take the internal couple produced by the compression and tension. So meaning, hindi mo kailangan memorize. You can derive it considering this stress diagram, considering the stress of the concrete and the tension produced by the rebar. Okay? Then another way is yung kukunin mo yung centroid. Okay, di ba? Transform formula. So i-convert mo yung steel NAS into equivalent concrete section. Then this one is KD. This one is B. Okay. Solve for INA. Okay. So after solving for INA, so we know that stress is equal to MC over I. Okay. So I and A. So considering concrete, so FC is equal to MC times C over INA, or just simply MC is equal to FC INA divided by C. So in this case, ang C is equal to, ito yung centroid natin, C is just simply equal to KD. So the distance from the centroid to the outermost fiber in under consideration. Same true with Fs. So Fs is equal to Ms times C, okay? C in steel divided by I and A. But this I and A is based on concrete section. So since we are solving for the moment capacity or the stresses considering steel, so we just divide this by N. So parang baliktad lang. Dito, convert natin yung steel into concrete, makuha natin yung moment of inertia. So dito naman, convert natin yung moment of inertia considering steel. So divide naman natin yung moment of inertia by value of N. So this CS, okay, or this distance from the centroid to the centroid of steel. So this is just simply, so this is, if this is the effective depth, so this one, D minus K D. So CS is just simply D minus K D. So dapat yung solve yung value ng MC o ng MS saka MC is same lang dun sa lalabas dito. Okay? So any question for singular reinforced beam before we continue on the design of doubly reinforced rectangular beam? So may questions?
Sir, may
Yes.
tanong lang po, clarification.
Yes.
Yung sa N po ba, rounded off po ba or yung whole number lang po kukunin?
Whole number lang kukunin. Yung sa other books, okay? Sa other books, kinukuha nila yung value ng N up to decimal, 9.82 to 9.282. So kinukuha nila yung value na to. But as per NSCP, i-round up mo lang siya into whole number. So let's say this one, N is 9. But for example, nakuha mong N is 9.998. So this considered as 10. So rounded mo lang siya to the nearest whole number. Let's say for example, your N value is 9.5. So what will be your N? Anybody? So nasa gitna siya, di ba? So ano yung rule natin sa mathematics? So ang rule natin is take a look at the next number. So 9 is odd number. So meaning, pag ni-round up natin yung 9.5 to the nearest whole number, so it will become 10. So if, for example, 10.5, how do you round up 10.5 to the nearest whole number? So 5, the next number is 0. So 0 is considered as even number. So this will become 10. So let's say for example 11.2. So this will 12.5 rather 12.5 kunwari 12.5. So the next number is even number. So this will give an N of 12.0 or just simply 12. Okay?
Thank you, sir.
Okay, any clarifications or questions before we continue with the doubly reinforced rectangular beam? Okay. So I suggest that you take this one, considering the moment of inertia, solve by yourself para maging practice solving ninyo. Okay. So for doubly reinforced rectangular beam, so in doubly reinforced rectangular beam, just simply parang siya, parang dalawang beam lang siya. Okay. So yung doubly reinforced rectangular beam natin, we have tension reinforcement plus compression reinforcement. Although in real situation, there's no such thing as singly reinforced rectangular beam. Although we designed the beam as singly reinforced rectangular beam, but by code requirement, we have we need to provide at least 2 bars, okay, at least 2 bars, okay, on the other side, on the other face of the other side of the beam. So number one purpose is, if you are going, or of course we are going to provide stirrups, okay, imagine if there is no, okay, there is no bars on the other side. So during pouring, there is a tendency that these stirrups, okay, ma-displace lang siya. Okay? Second, this additional, or the top bars or the compression bars will serve as additional capacity of the section, especially if you're going to consider deflection. Okay? So, di ba yung deflection natin, okay, for simple supported beam, the deflection is 5WL to the 4th over 384 EI. So, meaning, if we provide compression, okay, if we transform this beam, so the transformation will be compression bars plus compression concrete, and then tension reinforcement. So meaning, lalaki yung centroidal moment of inertia natin due to presence of compression bars. So this will reduce the deflection, since the deflection is inversely proportional to moment of inertia. Habang lumalaki yung moment of inertia mo, lumiliit yung value ng deflection natin. Okay. So, the double reinforced rectangular beam is just simply one single reinforced rectangular beam, okay, plus a fictitious beam with compression and tension reinforcement. So the compression reinforcement, so we can denote this one as AS prime. Then the tension reinforcement, considering single reinforced beam, is AS1. And the fictitious beam, tension reinforcement is just simply AS2. So meaning AS, the total AS, so tension reinforcement, is just simply AS1 plus AS2. So the moment capacity is equal to M1 plus M2. So M1 is the moment capacity considering single reinforced rectangular beam, and M2 is the moment capacity considering the internal couple created by the compression and tension reinforcement. So the distance from the centroid of the compression reinforcement to the outermost fiber is denoted as D prime. So the internal moment or the internal couple, okay, has a lever arm of, if this is D, or the effective depth, the lever arm for this fictitious beam is D minus D prime. So if we take moment about compression or tension, M2 is just simply AS2 Fs times D minus D prime. So same true with compression reinforcement, AS prime times Fs, okay, compression steel, times D minus D prime. Okay? But for this one, so ito lang yung formula natin dun sa single reinforced rectangular beam. Okay? But there are cases that FCS is not equal to Fs. Okay, meaning if FCS or the compression reinforcement okay, is less than Fs, okay? So meaning the compression reinforcement does not yield. Okay? But if your FCS is greater than your Fs, the compression steel is yielding. Okay? So ano ba yung ibig sabihin pag nag-yield? So ibig sabihin, before failure ng concrete, magkakaroon muna ng cracking yung beam natin. Okay? As I said before, pag may cracking yung beam natin, since yung tension steel natin, yung steel natin, okay, during testing, pag hinatak mo siya dyan, hindi naman siya abrupt yung masisira yung steel. So dahan-dahan pa siya, mag-elongate pa siya, okay, haba pa siya, okay, hanggang dumating sa point of rupture o yung point na mapuputol na yung steel reinforcement natin. Samantala yung concrete natin, sa testing natin, di ba? May nag-apply tayo ng compression sa universal testing machine. Di at nakikita nag-elongate yung concrete natin. Pero pag nag-crack na siya, diretso bagsak na siya. Kaya mas maganda na dapat mag-yield yung tension reinforcement before yielding ng concrete portion. Okay? So, one purpose of using double reinforced rectangular beam is sometimes architectural. Okay? So, there are cases minsan na limited tayo dun sa H natin. Okay? So, siyempre, kung ito yung floor-to-floor height natin, so standard floor height for residential or building is 3 meters. So imagine if the architect wants the space or the floor-to-ceiling height to be mas maluwang, so the tendency is ililimit niya tayo sa designing ng H. Kasi di ba, pag titignan natin sa cross-section, kung ito yung beam natin, di ba ganyan yung natin. So ang kadalasan, pag naglalagay tayo ng ceiling, of course, below the beam. Kasi minsan mas magandang tignan na yung ceiling natin, wala ka nakikitang biga. So habang lumalaki yung clear height mo between floor and ceiling, mas yung feeling mo, malaki yung bahay. Saka yung airspace, mas malaki. So hindi siya ganun kainit. Unlike na pag masyadong malaki yung H mo, okay, although in reinforced concrete design, okay, the deeper the beam, mas effective siya. Kasi lumalaki yung moment of inertia natin. Kasi ba yung moment of inertia natin is BH cubed over 12. So, directly proportional yung moment capacity, okay, sa cube ng height natin. Okay? So, pag masyadong ginawa mo efficient yung beam mo, ma-sacrifice naman yung clear floor to ceiling height mo. Masyadong mababa na siya. Okay? And then, of course, another reason para mag-double reinforce is, again, to reduce the deflection. So, siyempre, di ba, yung beam natin masyadong mabigat. So, habang lumalaki yung beam natin, bibigat siya. So, mas malaki yung magiging deflection niya o mas bibigat yung structure natin. So, the tendency is pag masyadong mabigat yung structure natin, okay, yung foundation natin ay masyadong lalaki. Pero, mas mahal yung double reinforced rectangular beam compared sa design ng single reinforced rectangular beam. So imagine, ang kilo ng bakal is, right now, is 35 pesos per kilo. Okay? Imported pa. Samantalang yung concrete natin, readily available sa market, local lang sa atin, local lang siya, local materials siya, napakadaling gawin. Okay? Kaya lang, of course, depende pa rin dun sa requirement ng owner. Okay? So number one, nag-dictate yung owner, yung architect. Okay? Then of course, if you want to minimize the weight of your beam, okay, so in terms of structure, para minimize mo yung weight niya, with yung foundation mo, so gagamit ka ng doubly reinforced rectangular beam. Okay. So, so this is just the review, okay, the summary of the single reinforced rectangular beam. Okay. So, just like for the single reinforced rectangular beam, using the transform area, so ang ginagawa lang is yung compression steel, transform natin into equivalent concrete. Okay? So, same true with the tension reinforcement. So, for the tension reinforcement, N times AS. Okay? But for compression steel, okay, the capacity of the compression steel is bigger than the capacity of tension steel. That's why in compression steel, the transform area is just equivalent to N, okay, minus 1 times AS. So, di ba yung concrete natin, okay, ito yung compression bars natin. So, this compression bars will reduce, okay, will reduce the volume of the compression concrete. But for compression, mas matibay yung compression steel natin ng twice. So the equivalent transform area for compression steel is 2N times AS. So we just subtract the area occupied by the steel. Kaya 2N AS minus AS. So 2N minus 1 times AS. So just simply 2N minus 1 times AS. Okay? So to illustrate that, let's try this sample problem. Okay? A rectangular beam with dimension 450 by 700 millimeter height, okay, with 428 millimeter diameter compression bars, and distance from the centroid to the bottom of the beam or socket of the beam is 75 millimeter, and the distance from the centroid of the compression steel using 325 millimeter diameter bars is 62.5. So this 62.5 stands for the prime. So ang D natin dito, okay, so ang D natin is just simply 700 minus 75 millimeter, just simply 625 millimeter. Then the lever arm, considering the compression steel, is equal to 562.5. So just simply equal to 700, the total height, minus D prime minus 75. So similar to single reinforced rectangular beam, of course, we need to determine for the value of N. So the value of N, okay, so just simply equal to ES over EC, or just simply 9.35, then rounded, okay, the whole number rounded to the whole number, so the value of N is equal to 9. Then for the compression steel, AS and AS prime, so for the tension steel, so the area of 420 diameter bars is equivalent to 2,463 millimeters squared. And the compression steel AS prime, okay, is equal to the area of 325 millimeter bars. So just simply equal to 1,473 millimeters squared. Then we convert, okay, the tension steel to equivalent concrete, which is equal to NAS. So NAS, N times the 9 times the area of tension steel, is equal to 22,167. Okay. Then for the compression steel, so the equivalent area is equal to 2N minus 1 times AS prime, or just simply equal to 25,041 millimeter squared. Okay, so knowing for the equivalent area or the converted area of steel into concrete, okay, so this is the transform method or the transform section of the beam. Okay, then from the transform section, we need to define the location of the neutral axis. So the location of the neutral axis is just simply equal to the area above, the moment of area above, okay, the moment of the moment of area above is equal to the moment of area below. So from that, okay, we can solve for the value of x to be 177.12 millimeter. So knowing for the location of the neutral axis, so we can now solve for the moment of inertia. So the moment of inertia is the moment of inertia of this rectangular concrete section, which is equal to 450, okay, times x. So 450 times x cubed divided by 3. So moment of inertia about the base, okay, of the rectangle. So 450 times 177.12 divided by 3 plus the moment of inertia of the equivalent compression steel to the centroid, which is equal to AD squared, diba? AD squared. So the A is the area and D is the distance from the centroid of the steel to the centroid of the transform section. So which is equal to area of steel, compression steel is 25,041 times the D squared. So ito yung distance of steel to the centroid plus the moment, okay, or the moment of inertia below, or the moment of inertia of equivalent tensile reinforcement. So it's equal also to AS, okay, AS of compression times D squared. So this will give a value of centroidal moment of inertia of 5,609.08 times 10 to the 6 millimeter to the fourth. So knowing for the value of moment of inertia, okay, so we can now solve, okay, for the moment capacity. So di ba, stress is equal to MC over I. So this is the basic formula of stress. So considering concrete, okay, the moment capacity of concrete is just simply FC times INA divided by distance from the centroid, okay, to the outermost fiber of compression concrete. So this will give moment capacity of concrete to be 294.51 kilonewton meter. Then considering the compression steel, so the compression steel similar to the basic formula of stress, okay. So you just, okay, so dito yung INA, okay, is based on concrete. So just divided by 2N, okay. So i-transfer lang yung 2N dun sa kabilang side. So this MS prime or the moment capacity of the compression steel is equal to FS prime, okay, INA times 2N times C of C. So FS, okay, so for page 60 reinforcing bars, ang FS natin is either 170 or 165 megapascal. In some other books, they are using 165 megapascal, but for NSCP, the suggested value is 170 megapascal. So considering 165 megapascal, okay, so Fs is 165 megapascal. So this one, we assume that the compression steel will yield. So 165 times moment of inertia, okay, divided by 2 times N times the lever arm. So the lever arm of the steel to the centroid is equal to the X, okay? This value, X minus D prime. Ito yan. X minus D prime. So this will give the moment capacity of 448.58 kilonewton meter. So same true with the tension reinforcement. So for the tension reinforcement, okay, the moment capacity is 229.6 kilonewton meter. So therefore, from these three given values, okay, the moment capacity is the smallest. So 229.6 kilonewton meter. So meaning, mag-yield muna yung steel, mag-fail muna yung steel before mag-fail yung compression concrete. So after mag-fail nung steel, mag-fail yung concrete bago pa lang mag-fail yung compression steel. So again, good pa rin yung design niya kasi una mag-fail yung tension reinforcement. Okay? So yung double reinforce, parang single reinforce lang yan. I-convert mo lang equivalent steel. Okay? Ang pagkakaiba niya lang, sa single reinforce, wala ito. Okay? Wala yung compression steel. Sa double reinforce, meron yung compression steel. Okay? So pag na-convert mo siya into transform area, you can now solve easily for the either stress or the moment capacity of the section. So any question for the double reinforced rectangular beam? So parehas lang siya ng single reinforced sa pagkuha ng moment capacity. Merong clarifications? Okay. So let's try this sample problem. So this one is a design problem wherein, okay, a simple supportive beam with a span length of 5.5 meter and total load of 36 kilonewton meter. So it's this 36 kilonewton meter is the superimposed, so excluding the weight of the beam. Okay? So in practice, normally we add additional 20% to take care of the weight of the beam. Okay? So this 20% is just an assumption. So after design, okay, nakuha mo na yung section B and H. So we can solve for the weight of the beam, or just simply B times H times unit weight of concrete, 24.5 or 23.56 kilonewton per cubic meter. So take note that this 23.56 kilonewton meter is weight of concrete without reinforcement. That's why in the design, we use 24.5 or sometimes we just rounded to 25 kilonewton per cubic meter. So kasi i-add pa natin yung area o yung weight ng reinforcing bars. Di ba yung reinforcing bars natin, ang weight niya is 77. Okay? 77 kilonewton per cubic meter. Samantala yung concrete natin is 24 o 25 kilonewton per cubic meter. So times 3 yung bigat ng steel compared dun sa steel. So yung 25 na to, for heavily reinforced beam, pwedeng 25. But for standard beam, you can use 24.5. So anyway, during the exam naman, I will give you, or I will include what will be the unit weight of the beam to be use. Okay? So this one is okay, with the given size of beam, 250 by 400. So by the way, since given pala dito yung yung beam size natin, 250 by 400, okay? So we can determine the exact, okay? So the exact unit weight of the beam. Okay, so 0.25 weight of beam is 0.25, okay, times 0.4 times, let's say we use 25 kilonewton per cubic meter. So this will give 0.25 times 0.4 times 25. This will give a value of 2.5 kilonewton per meter. Samantalang yung 20% na assumption natin will give 36 times 0.2, 7.2 kilonewton per meter. So to simplify, okay, we use the value of actual weight of beam. Okay, 2.5 kilonewton per meter. But in any design problem, of course, hindi mo unknown yung values ng BNH mo. Okay, that's why we are using additional 20% for conservative design approach. Okay, but in the exam, if the beam dimension is given, use the beam dimension. So whatever is the beam dimension, we can easily solve. So in this case, the total weight superimposed plus weight of beam is just simply 36 plus 2.5, or just simply 38.5 kilonewton per meter. So in doubly reinforced rectangular beam, first we need to determine what will be the moment capacity of 250 by 400 millimeter beam. Okay? So if the capacity, okay, considering singly reinforced, is greater than moment capacity, actual moment capacity. So by the way, the moment capacity or the actual moment to be carried by your beam is just simply 1/8 WT L squared. Okay, so which is equal to 1/8 times WT, total load is 38.5 times L. So L of 5.5 squared. So this will give a value of 145.578 kilonewton meter. So let's say, for example, considering singly reinforced rectangular beam, okay, the moment capacity is greater than M, okay? So meaning singly reinforced rectangular beam. But if your moment capacity is less than actual moment of 145.578, so use doubly reinforced rectangular beam. Okay? So first, of course, in any problem, either singly reinforced rectangular beam or doubly reinforced rectangular beam, okay, we need to determine the value of K, okay, J, what else? Yun lang, kasi given na yung B and H natin. So, from H, you can extract the value of B. Okay, so in this problem, the F prime C is 21 megapascal and Fy of 276 megapascal. So 276 megapascal is equivalent to 140 megapascal na Fs. Okay? Then the beam is not exposed to weather, so meaning the concrete cover, okay, if the beam is not exposed to weather, the concrete cover CC is just simply equal to 40 millimeter. So here, we are advised to use 25 millimeter as main reinforcement or flexural reinforcement and 10 millimeter as stirrups diameter. So how are we going to solve for D? So D, okay, this is the beam. We have, okay, assuming double reinforced rectangular beam. Okay, we have concrete cover, which is equal to 40. Then we have diameter of stirrup, which is equal to 10 millimeter. Then the size of main reinforcement is 25. So another from centroid, we have 1/2 diameter of bar, or equal to 1/2 of 25 is 12.5 millimeter. So D is just simply H, total height, minus concrete cover, minus diameter of stirrups, minus 1/2 diameter of bar. So this will give, okay, 400 minus concrete cover 40, minus stirrups of 10 millimeter, minus 1/2 of main bars, which is 12.5. This will give a value of the 337.5 millimeter. Okay, so we have now B and D. So wala tayong problema sa B and D. Next is J. But how are we going to solve for J? So we know that J is equal to 1 minus K over 3. So we need first to solve for K in order to solve for J. So for design problem, okay, the value of K is this one. So design problem, K is equal to FC over FC plus Fs over N. So again, we need to determine the modular ratio N. So the modular ratio N, okay, is equal to ES over EC, or just simply 9.28 or 9. So we use N equal to 9. Then using the design formula for K, so K is FC over FC plus Fs over N. So with this will give a value of K of 0.378. And for J, okay, we can solve for J, which is equal to 0.874. Okay, so we have already K, we have J, we have B, we have D. So we can solve for the moment capacity, okay, of the concrete section considering singly reinforced rectangular beam. So ito yung formula na pwede natin gamitin. Ito, hindi na siya natin pwedeng gamitin kasi wala pa tayong value nung AS. So from this formula, M is just simply equal to, okay, 1/2, okay, times FC KJ BD squared. So ito yung tinatawag natin na M1. So moment capacity, di ba yung moment natin, total moment capacity ng double reinforced rectangular beam is simply M1 plus M2. So yung M1 natin, yun yung, okay, single reinforced rectangular beam. And M2 natin is yung moment capacity ng fictitious beam considering both compression and tension steel. So M1 is equal to 1/2. FC is 0.45 times F prime C of 25 megapascal times K of 0.378 times J of 0.874 times B. So ang B natin is, B natin, 250 times D. So ang D natin is 337.5. So 337.5 squared. So take note that for the moment capacity, okay, the moment capacity of the section, singular reinforced rectangular beam, is directly proportional to the D squared. So squared of D. So ibig sabihin, kaya sabi ko kanina, habang lumalalim yung beam natin, lumalaki yung moment capacity. So habang nilitan mo yung B natin, lumilit din yung D natin. So liliit yung moment capacity. So this will give a value of 0.5 times 0.45 times 21 megapascal times 0.378 times 0.874 times 250 times 337.5 squared. So this will give a moment capacity of 44.45 kilonewton meter. So can you double check kung tama yung sagot? O, mali yata. Okay. So mali yung pinag ko sa calculator. So the correct answer or the correct value is A. BD squared. So yung D, so mali yung D dito, this should be 337.5. Okay, F prime C times 0, FC 0.45. Okay, times 378. So mali ito. So 0.5 times 250. Okay. 0.5 times 250 times 337.5 squared times 0.45 times 21 times 0.378 times 0.874. Error. 0.5 times 250 times D 337.5 squared times FC 0.45 times 21 times K 0.378 times J of 0.874. Okay, divide 1,000. Okay. So this will give a value of 44, okay, 0.452 kilonewton meter. So masyadong maliit yung moment capacity nung section natin. Okay? So this is M1. So M is equal to M1 plus M2. So yung moment, okay, to be carried by our section is 145.578. So 145.578 is equal to M1. This is 44.452. Okay, times plus M2. So M2 is equal to 145.578 minus 44.452. So 101.126 kilonewton meter. So yung moment na yan, M2 is this one, yung fictitious beam natin. So, yung AS2, saka yung AS prime. So, this value, D prime. So, yung D prime natin, okay, yung D prime natin, ito yung section. Ito yung beam. So, yung D prime natin, distance from the centroid of the compression bars to the outermost fiber in compression concrete. So, this value is 40. This stirrups is 10. And this one is 1/2 the B, or just simply 1/2 of 25 is 12.5. So your D prime is equal to 40 plus 10 plus 12.5, or just simply 62.5 millimeter. Okay. So meron tayong value nung D. So ito is 62.5. So yung D natin is 337.5 millimeter. So considering the internal couple, so M2 is equal to AS2 Fs times D minus D prime, or just simply AS2 is equal to M2 over, okay, Fs times D minus D prime. So ang AS2 natin is, M2 natin is 101.126 times 10 to the 6 Newton millimeter divided by Fs of 140. So D minus D prime is 337.5 minus D prime of 62.5. So this will give an AS value of 2,626.65 millimeter squared. Okay? So, yung AS prime naman natin, okay, yung AS prime natin, yung compression steel natin, is just simply equal to M2 is equal to AS prime, Fs prime, or sometimes in other books, yung Fs prime is just simply equivalent to F no compression steel. Okay? So let's say we call this one as FCS. Times D minus D prime. So initially, we assume that the compression steel will yield. So meaning, if we assume that the compression steel will yield, FCS natin will be equal to Fs. So if your Fs is equal to FCS, so same lang siya nung value nung AS2. Okay? But we need to determine for FCS. So how are we going to determine for FCS? Okay. Meron tayo na isang slide. Okay. So in order to solve for the value of FCS, so take a look at the strain diagram. So the strain diagram is simply like this one. Okay? Ito yung steel. Ito yung piece of S. So, sa beam natin, ito yung compression steel natin. So, ease of compression steel. Naman strain of concrete. So, this one is the prime. So, this is KD. Okay? So, by ratio and proportion, similar triangle, ease of C is to KD. Okay? So, the big triangle is equal to the small triangle. So, ratio and proportion, ease of compression steel or strain of compression steel divided by, so this one is KD minus D prime. So, KD minus D prime. Or just simply, strain of the compression steel is equal to strain of concrete, okay, times KD minus D prime over KD. Okay. So kayo na sinabi natin na yung compression steel is twice yung strength niya compared dun sa tension steel. Same true with the concrete. Yung strain ng concrete, okay, is smaller compared to the strain of steel. Mas matibay yung steel. So kaya nagdadagdag tayo dito ng times 2 or a factor for creep load. Okay? So therefore, we know that strain, okay, strain is equal to stress over modulus of elasticity. So ease of CS, strain of compression steel, okay, or just simply FCS divided by modulus of elasticity of steel or compression steel is equal to, so this EC is just simply equal to FC divided by ease of C. So times KD minus D prime over KD. So 2. Okay? So if you write the equation, FCS is equal to 2 ES ECS over EC times FC times KD minus D prime over KD. So ECS, so for all steel, modulus of elasticity is constant to be 200 times 10 to the 3 megapascal o 200 gigapascal. So ES, di ba? ES over EC is just simply equal to N. So this will give FCS 2N FC times KD minus D prime over KD. So ito ngayon yung value ng FCS. Okay? So from the problem, FCS is equal to 2 times 9, 2N times FC of 0.45 times 21 times KD. So ang KD natin is, ang K natin is 0.378. 0.378 times T of 337.5 minus D prime. So D prime natin is 62.5 divided by KD, 0.378 times 337.5. So FCS is okay, so 0.378 times 337.378 times 337.5 minus 62.5 divided by 0.378 times 337.5 times 0.45 times 21 times 2 times 9. So FCS is 86.77 megapascal. So this is less than Fs of, ang Fs natin? 140. So this is less than 140 megapascal. So meaning, if your FCS, okay, if FCS is less than Fs, so compression steel, okay, the compression steel will not yield. But if your FCS, okay, is greater than Fs, compression steel yield. So if your compression steel will not yield, so use FCS computed. But if your FCS is yielding or FCS greater than Fs, so use FCS is equal to Fs equal to 140 megapascal. Hindi kasi dapat mag more than 140 kasi yun lang yung yielding capacity ng steel natin, 140 megapascal. So beyond that, magpipail na yung structure natin. So ibig lang sabihin kasi nito na yung compression steel yield, okay, magpipail yung compression steel. Okay? So knowing for the value of FCS, we can now solve for AS prime or AS, okay, compression steel. So AS prime is equal to M2 101.126 times 10 to the 6 divided by FCS of 86.77 times D 337.5 minus 62.5. So AS prime is 101.126 into the 6 divided by 86.77 times 337.5 minus 62.5. So AS prime is 4,237.996 millimeter squared. So your total AS tension, AS is just simply equal to AS1 plus AS2. Okay. Nasolve natin yung AS2. But what is AS1? So ang AS1 natin, okay, AS1 is just simply M divided by Fs, okay, times JD. But yung moment natin dito is yung M1, moment ng singly reinforced rectangular beam, which is equal to yung capacity natin kanina, 44.452. So 44.452 times 10 to the 6 Newton millimeter times Fs of 140 megapascal times J. J natin is 0.874 times D of 337.5. So AS1 is 44.452 to the 6 divided by 140 times 0.874 times D of 337.5. So AS1 is 1,076.41 millimeter squared. So your AS total or tension reinforcement is 1,076.41 plus 2,626.65. So this will give minus 2,626.65. Okay. Then 76.41 plus 2,626.65. So this will give a value of 3,703.06 millimeter squared. Okay? So, nagdagdag tayo na isang slide. Okay. So in summary, we have $250. We have 250 by 400 beam with AS prime equal to 4,000, okay, 4,238. 4,238 millimeter squared, and AS, okay, AS of 3,703.06, 3,703.06 millimeter squared. So using 25 millimeter bars, the total number of compression reinforcement is equal to 4238 millimeter squared divided by the area of 25 millimeter diameter bars. So the area of 25 millimeter diameter bars. So N is 4238 divided by pi over 4 times 25 squared. So this will give 8.63. Okay, so say 9 diameter 25 mm. Then this one, the tension reinforcement 3703.06 divided by the area of 125 millimeter diameter bars. So this will give 7.54. So say 8 diameter 25 millimeter. Next is we need to check what will be the arrangement of this bar. So makita ninyo, masyado marami yung bars kasi masyado malaki yung moment natin. So, paano natin pagkakasyahin yung 9 na bakal? So imagine we have only 250. Okay? We have only 250 millimeter, but we are required to put 9 bars. So these 9 bars, okay, bawa, kasya kaya yung wala. Okay. Tatlo. Pag tatlong bakal, so we said tatlong layer ang gagawin natin. So there are several possible arrangement. It would be like this one. 2-bar bundle on the first layer. Okay, 2-bar bundle on the first layer. Then another single bar on the second layer. So from the code requirement, the distance, clear distance between layers should be at least or should be 25 millimeter or more. Okay. Then the clear distance between bars should be 25 millimeter diameter of bar or 4/3 of the size of the aggregate. So since in our problem, we don't have the size of aggregate, but normally for beams, we are using 3/4. So we are using 3/4, okay? We standard practice 3/4 gravel ang ginagamit natin for the beams. Okay? So let's say for example, 3/4 siya. So 4/3 of 3/4 is equal to 25 millimeter or 1 inch. Okay? Then the diameter of bar is 25. So another requirement. Then 25 millimeter. So meaning, ang required clear distance natin should be at least 25 millimeter. So if we have 250 millimeter bars, then we have stirrups 10. Then we have a concrete cover of 40. We have 10. Okay. The clear distance C. So C is equal to 250 minus concrete cover on both sides of the beam, 2 times 40. Diba? Dalawang side. Minus dalawang stirrups. Okay, dalawang 10. Okay. What else? Minus tatlong 25. 3 times 25. Yung size ng bars natin. So divided by, we have 2. Okay? 2 spaces. So the clear distance is 250 minus 2 times 40 minus 2 times 10 minus 3 times 25. So divided by 2. So we have 37.5 millimeters. So this is greater than 25 millimeters. So meaning the 3-bar bundle, a 2-bar bundle on the first layer and another single bars composed of 325 millimeter bar, the second layer, will satisfy the code requirement of clear spacing. Okay. So, pasok ngayon yung 9. So, kung pasok yung 9, pasok din yung 8. So, sa 8 naman, mangyayari ang arrangement niya sa bottom, okay, pwedeng ganito, okay, 2-bar bundle dun sa first layer and then another bars on the 2 bars on the second layer. Okay. Kaya lang, one more. Kailangan pa nating checkin ulit. We have another things to check. Okay. So, ang in-assume natin kanina in designing for the beam, okay. Ito yung beam natin. Ang in-assume natin, okay. Dali lang, nag-off yung ano ko, ilaw. It means 7:30. Okay, so for a while lang eh. Okay. So sineset ko kasi yung ilaw ko na 7:45, mag-o-off siya. Para minsan kasi nakakalimutan ko na na sumusobra ako sa trabaho, inaabot ako ng past 10. May pasok pa kinabukasan. So para ma-alert ako na kailangan ko nang matulog o kailangan ko nang mag-start na mag-ayos ng gamit, sineset ko siya na 7:45. Okay. So going back to the beam, ang assumption natin kanina, ito is 62.5. And then dito kanina, ang assumption natin, ang D natin is 337.5 millimeter. Okay? But with this detail, hindi na siya conforming o mas iba na yung magiging centroid ng bakal natin. Kasi ang ibig sabihin nito, yung distance from the centroid of the compression bars to the top of the beam is 62.5. Same true with this one. The centroid of the tension reinforcement at the top of the beam is 337.5. Okay. In this case, hindi na siya 62.5 and 337.5. Okay. So first, let's check the compression reinforcement. So for the compression reinforcement, we have 1, 2, 3, plus another 3 bars on the next layer. So meron tayong stirrups, meron tayong concrete cover. Okay? So kunin natin ngayon yung centroid ng compression reinforcement. So ito, concrete cover is 40. Itong stirrups natin is 10. So how do we get for this centroid of this bar? So by Barigdon's theorem, see if we take this one or here as your reference point, okay? So this one will have a lever arm of 12.5. Kasi 25 siya, di ba? Then this one will have a lever arm of 25 plus 12.5. We have 37.5. Then this one will have a lever arm equal to, so this distance is 25 millimeters. So this one, we have 37.5 plus 25 plus 1/2 diameter of bar. So 1/2 times 25 or just simply equal to ganyan. 1 to 37.5 plus 25. Okay. So distance between layers, clear distance between layers is 25 plus 1/2 of 25. So this will give a value of 75. Okay, so by Barigdon's theorem, okay, A times Y is equal to summations of A, Y. So the total area is the total area of 9 bars. So 9, okay, times bar Y is equal to, so this first layer, okay, we have 2 bar bundles. So yung first 3 bars will have 3 times lever arm of 12.5 plus the second layer of the first layer, we have again 3 times 37.5 plus the second layer, single layer bars, 3 times 75. So Y will be, so paras lang yan. In terms of area, since pare-pares na mga 25 millimeters siya, ginamit ko lang number of bars. Okay. So 3 times 12.5 plus 3 times 37.5 plus 3 times 75 divided by 9. So this will give a value of y of 41.67 millimeter. So ibig sabihin, yung centroid niya is nandito. This is 41.67. So therefore, if this is 41.67, the actual y or the actual d prime is equal to 40 concrete cover plus stirrups diameter 10 plus 41.67. So this will give the actual d prime of 40 plus 10 plus 41.67. So the actual d prime is now 91.67. So ito yung assumption lang natin kanina. So ito na ngayon yung bagong d prime. So what does it mean? So ibig sabihin, yung centroid mo, nung bakal mo, lumapit dun sa centroid nung beam. So pag lumapit yung centroid ng beam natin, di ba yung I natin is directly proportional to distance from the neutral axis, squared to the distance of the neutral axis. So pag lumit yung I natin, okay, di ba? Stress is equal to MC over I, or M is equal to stress I over C. So the moment capacity is the second din natin yung centroid naman natin ng bottom bars natin. Yung walong 25 millimeter diameter bars. So same too with this one. Okay? For example, ito yung stirrups natin. We have 1, 2, 1, 2, 1, 2. Ganito yung arrangement natin. Okay? So ito, ang distance niya is 12.5. Ito, ang distance niya is 37.5. Ito, ang distance niya is 75 millimeters. So the only difference is, sa bottom bars, yung second layer natin, dalawang bakal lang. So therefore, ang Y bottom natin, so ito yung Y top, ang Y bottom natin is equal to 3 times 12.5 plus 3 times 37.5 plus 2 times 75 divided by 9. Okay? So 9. So therefore, ang Y bottom natin, so 3 times 12.5 plus 3 times 37.5 plus 2 times 75 divided by 9. So ang Y bottom natin is equivalent to 33.33 millimeter. So 33.33. So meaning, kung meron pa tayo ditong concrete cover na 40, okay? So yung D natin ngayon, actual D, based on the design, is equal to 400. Yung total height ng beam natin is 400 millimeter. Minus concrete cover of 40. Minus diameter of stirrups na 10. Okay? Minus centroid ng bars natin. Mula rito, okay, ang centroid ng bars natin is 33.33. So, ibig sabihin, banda rito yung centroid ng bars natin. 33.33 minus 33.33. So, this will give a value of 400 minus 40 minus 10 minus 33.33. So, this will give 316.67 millimeter. Again, lumapit na naman sa centroid yung tension reinforcement natin. So, ibig sabihin, pag lumapit sa centroid, liliit na naman yung moment of inertia niya. Na yung moment of inertia, directly proportional to sa moment capacity. So, liliit din yung moment capacity. So, from this rebar arrangement, what next is to determine the capacity of the section. So, tapos natin i-design, na-layout natin yung bakal, ayun, check naman natin yung sectional capacity o yung flexural capacity ng section. Of course, yung kanina, sinod natin yung bakal natin, okay? Pero ang nakuha natin kanina, yung bakal natin is, may bakal natin kanina. Okay, so okay na ito. Nakuha natin 8.63, ginawa natin 9. 7.2, ginawa natin 8. So, ibig sabihin, ni-round off naman natin. So, since dimihan natin yung bakal dito, lumaki yung area nito, maaaring lumaki din, of course, lumaki din yung moment capacity. Pero, dahil doon sa arrangement ng bakal natin, na lumapit sa centroid, yung mga bakal natin, maaaring kulangin na yung strength ng beam natin. So, from this, we are going to determine the moment capacity of the doubly reinforced rectangular beam na didesign natin. So, dagdag tayo ng slide. Okay. Okay. So, balik tayo sa investigation this problem. Okay. AS prime, AS. Ngayon, lagay natin ngayon yung actual D natin. So, yung actual D natin is 91.67. Then yung D, okay, D prime, actual D is now, actual D is 316.67. So, 316.67. Okay. So, from this, we transform this into equivalent transform area ng concrete. So, let's say, for example, this is our centroidal or the centroid of this section. So, NAS, this one is, okay, 2n minus 1 times AS prime. Okay. And then this one is n times AS. Okay. So again, let's say this is X. Okay. So similar to single reinforced rectangular beam, we need to find the centroid of the transform section. So this centroid of transform section, this one is 250. Okay. So the area, moment of area above is equal to the moment of area below. So the moment of area above is 250 times X over 2. Okay? Plus 2n. So ang n natin is 9. So 2 times 9 minus 1 times AS. So ang AS natin is okay, 9 okay, times area nung 25 millimeter diameter bars. Okay. So ito yung area above is equal to the area below. So the area below is N 9 times AS. So yung area nung okay, 9 na bakal. So N AS 5 over 4 times 25 squared times 8 bars, okay, times the lever arm. So the lever arm is, if this is D, so D minus X. So dito rin, dapat yung lever arm niya is X minus D prime. Okay? So we have value of D and D prime. So substituting the value of D and D prime, so X is equal to, so kindly solve the value of X. Okay, please solve the value of X. Okay, buti nga ngayon, yung calculator na ginagamit ninyo, meron na siyang quadratic equation. Meron na siyang, tawag yan, solving value of x, kahit quadratic siya, kahit cubic siya, kanya solve yung value ng x. So yung time namin dati, yung calculator namin basic lang. Addition, yung midas, multiplication, division, subtraction, addition, tapos square root, saka mga sine, cosine. Wala pa siyang pag-solve nung exponential, wala pa siyang, ngayon meron na meron calculus yung calculator ninyo. Kaya mas swerte kayo compared sa amin. Dati sa amin, minamano-mano pa namin eh. So quadratic equation, solve for x, okay? Masyadong mahaba. Sa so, ito, pwede nyo siyang input sa calculator, kukul niyo yung value nung x. Okay, so please solve for the value of x. Okay, everybody, please solve for the value of x. Okay, pinakuha value of x is 91.812. About the others, can you check?
Yes, sir. Same lang din po sa nakuha.
Okay. So 91.812 millimeter. Okay. So knowing for the value of x of the centroid, because in the centroid, we can now solve for the moment of inertia. So the moment of inertia, INA, is equal to, so BH cube over 3, so 250 times 91.812 cube over 3 plus 2n minus 1. So 2 times 9 minus 1 times the area of 9 25 millimeter diameter bars. Okay, times d squared. So ang d squared is, okay, x minus d prime. So x is 91.812 minus d prime of 91.67. So imagine, masyadong malapit na yung bakal natin sa centroid. Okay? 91.67 versus 91.81. Okay? Plus yung tension bars, 9 times n. Okay. And AS, 9 times AS, so the area of 8 na 25 millimeter diameter bars squared times D minus X. So D natin is 316.67 minus X of 91.812 squared. So INA, okay, the central moment of inertia is equal to, please solve. Okay, ilan yung INA? Okay, may bali na kayo? Okay, so, okay, thank you, Miss Adriana, Palyara, Richard, and Rafael, Delan, Nicole. So the value is 851 times 10 to the 9 millimeter to the fourth. Okay. So from the stress is equal to MC over I. Okay. So from the basic formula, okay. So considering steel, considering the concrete, okay, Okay, considering concrete. So from the basic formula, MC over I. So the moment is equal to stress multiplied by I divided by C. So for concrete, MC is equal to 0.45 F prime C, which is 21, times moment of inertia of 1.851. So 1.851 times 10 to the 9 divided by the distance from the centroid to the outermost fiber in compression. We see what the value of X. So X natin is 91.812. 91.812. So MC is 0.45 times 21 times 1.851 e to the 9 divided by 91.812. Okay. So this will give a value of 190.52 kilonewton meter. So considering compression steel, okay, MCS is equal to, okay, so the compression steel, okay, Fs is 140 megapascal, Fs times I, 1.851 times 10 to the 9, okay, divided by I. So yung I natin dito, okay, is based on concrete. So divide natin siya sa 2n. So 2n, 2 times 9 times the distance from the centroid, okay, to the compression steel is x minus, okay, x minus d prime. So x natin is 91.812 minus d prime of 91.67. Okay, so this will give a value of 140 times 1.851 e to the 9 by 2 times 9. Okay, times 91.812 minus 91.67. So the moment capacity, okay, mali ata, 140 times 1.851 e to the 9 divide 2 times 9 times 91.812 minus 91.67 by 1,000. Okay, so masyadong malaki yung moment capacity ng compression steel natin. Nasa 101,384 kilonewton meter. So can we check this one? Okay. So for steel, tension steel, MS is equal to 140 times 1.851 times 10 to the 9 divided by N. So N is 9 times C. So C natin dito is, okay, D minus X. So D natin is 316.67. 316.67 minus X of 91.812. So this will give 140 times 1.851 e to the 9 divided by 9 times 316.67 minus 91.812. So this will give a value of 128. 128.051 kilonewton meter. So pa-check nyo yung compression steel, ganun talaga kalaki. 140 times 1.851 e to the 9 divided by 2 times 2 times, okay, 2 times 9 times 91.812 minus 91.67 by 1,000. Tama, 101,000. Okay. Okay, thank you, Alisa and Paz. Okay. So from this, the moment capacity is, okay, again, una nag-fail yung steel natin. So the moment capacity is 128.051 kilonewton-meter. So ano yung actual moment natin? So actual moment natin is 145. So the actual moment is 145.578. Okay. So moment capacity is 128.051 kilonewton-meter. This is less than the actual moment of 145.578. So 145.78 kilonewton-meter. So ibig sabihin, lumit nga yung moment capacity niya kasi yung centroid ng bakal natin, okay, from 62, ang assumption kasi lagi natin is one layer. So hindi pati alam kung ilang layer dabas na bakal. Same true with the tension reinforcements. Imagine from 62 naging 91.67. Then from 337.5 naging 316 lang siya. So ibig sabihin, kulang yung bakal natin. So mag-add ulit tayo ng another bars. So pag nag-add tayo another bars, okay. So let's say gawin nating siyam na bakal. So walang problema dun sa concrete. Pasado yung concrete natin, compression steel pasado. So ang kulang lang natin yung tension reinforcement. So pag nag-add tayo ngayon dito ng bakal, gawin natin 9. So on the revised calculation, gagawin nyo namang 9 na. So yung parehas na 9 yung top bars natin, 9.25 yung bottom bars natin, 9 na 25 din. Okay? So gawin nyo na to as your exercise. Okay? Or maybe as assignment na lang. So I give you this one as your assignment. Okay? To be submitted today. So kung sino yung unang pag-submit sa Google o dun sa unang makapag-comment dun sa Google Classroom natin, we'll have additional plus malaking 50 plus 20 points on your first quiz. Okay? So yung first, damihan natin, first 5 na makapag-submit with calculation or with solution, okay? 20 points yung first. Yung second, 15 points. Yung third, 10 points. Yung fourth, 5 points. And fifth, 5 points. Okay? So, i-comment nyo lang dun sa Google Classroom natin with picture lang ninyo, tapos i-send nyo as file. Okay? So, meron kayo additional points sa first quiz. Okay? So, yan yung design ng double reinforced rectangular beam. Okay? So, after designing, para lumalabas na after designing, after same with single reinforced rectangular beam. Pag lumabas na yung bakal ninyo, magiging multiple layer na siya, kailangan nyo check yung moment capacity. Kasi pag multiple layer na siya, lumalapit na yung bakal natin sa centroid. So pag lumapit yung bakal natin sa centroid, lumiliit yung moment of inertia na proportional siya dun sa moment capacity. Okay? So either single reinforced, double reinforced, okay? I-check nyo yung moment capacity. Kaya kanina, di ba, yung example natin, okay, sinolve natin yung moment capacity okay, using these bars. Okay, yung sample natin nung nakaraan. So more than siya dun sa strength ng bakal, ng beam. Okay. Okay, any questions? Okay. So another for your exercises. Okay, for your exercises, ito naman, ang given naman, investigation pa rin, kaya lang, the required is the stresses in the extreme fibers. So, any stress, okay, FC, okay, FC actual, FCS, and FS. So, lahat yung actual stresses. Okay, by stress is equal to MC over I. Okay, so pag concrete, okay lang siya. Pero pag steel, MC, MCC, okay, C ng concrete, I ng concrete, o yung INA. So pag steel naman, stress ng compression steel, moment. So yung moment natin, either okay, so given yung bending moment, so M times C, centroid ng compression steel divided by INA divided by 2N. Pag steel, compression steel at tension steel, stress ng steel is equal to M times C ng steel divided by INA divided by N. So try to solve, okay, so as your exercises para ma-practice kayo. Okay, so any question for double reinforced rectangular beam?
Sir,
Yes.
pwede po mahingi itong PDF po.
Yes, yeah, i-upload ko yung PDF dun sa, sa Google Classroom natin.
Okay po, sir.
Okay. Okay, some more clarifications or questions? Okay, so kung wala ng questions, so let's go to, so this one another problem, okay. So ito naman, the same doubly reinforced rectangular beam investigation, okay. So I'll give you this one as another exercises. Okay. Then next is T-beam and regular beam. Okay. So T-beam is the special type of a regular beam. Okay, wherein the beam, okay, actually in real situation, wala talagang rectangular beam for monolithic construction or for reinforced concrete, unless na gagawa kayo ng beam ninyo, okay? Tapos yung ibabaw niya is just simply steel decking or hindi siya monolithically constructed with the beam, okay? But in a case for slab and beam, cast monolithically, kasi ang pagcast naman nung floor natin, monolithic yung beam, yung slab natin with the beam. Okay. So this flanges will give additional compression to the beam. So imagine this one. This one is your beam, rectangular beam. Okay? So instead of, okay, para lumaki yung compression capacity ng beam natin, naglalagay tayo ng compression reinforcement. But aside from you putting compression reinforcement, we can use the flanges. So this, okay, so this wing or part of the slab will be considered as additional compression capacity of the section. Okay. So we have T-beam or the beam at the tributary weak. Okay. So meron siyang slab on both sides, T-beam. So this one another T-beam but L-shaped. So we have only one flange or one slab on the other side. Okay. So the only difference in determining for T-beam is how to determine the effective flange width. So this effective flange width, okay, merong requirement yung code o merong recommendation yung code. But this recommendation is based on experiment. So ibig sabihin hindi siya mathematically proven, but based on experiment or based on practice, they come up with the effective width of flange to be considered for edge beam, okay, L-type and T-beam na T-type. Okay. So ito yung slab natin. So typical construction of reinforced concrete wherein the slab is built monolithically. Although unang binubuhusan yung beam. Then after pouring the beam, binubuhos na yung slab. Pero minsan may makita kayong mga construction, binubuhusan nila yung beam hanggang dito lang talaga. So intentionally binubuhusan na yung beam tapos next is yung slab. So, yung ganyang case ng construction, hindi natin siya makonsider monolithic, okay? But we can consider this one as just simply rectangular beam plus slab on top. Or if you want to be monolithic, minsan lalagay tayo dito ng mga concrete epoxy para mag-bond yung old and new concrete. So, nangyayari kasi kadalasan yan sa mga residential construction wherein masyadong malaki yung volume ng concrete na ibubuhos natin. So, normally pag residential construction, mano-mano yung buhos. Okay? Or meron man mixer but limited lang to 2 or 1 bagger. So, yung 1 bagger natin is around ilang cubic lang yon. So, halos 0.1 cubic lang yung 1 bagger na mixer. So imagine if you have a typical floor with kunyari, yung standard na bahay natin, kunyari 80 square meter. So 80 square meter times ng total thickness ng slab natin, let's say 0.1. So meron kang 8 cubic meter or slab alone. So normally, yung beam natin comprised of around almost same as sa slab natin. So around 16 cubic. So imagine 16 cubic, how long will you haluin mo siya mano-mano kung wala kang mixer? 16 cubic, okay, requires 120 bags of cement. So imagine how long na mano-mano mo haluin yung 150 bags. So di ba pag naghalo tayo isang bag, kadalasan isang bag lang, di ba? Isang bag o 3 bags o 2 bags kasi limited lang yung space natin. So 2 bags. So ibig sabihin kailangan maghalo ng 60 times. So kung maghalo ka ng 60 times, isang halo mo is 10 minutes. So meron kang 600 minutes. O meron kang 10 hours para haluin mo yung 16 cubic. Assuming 10 minutes, napakabilis maghalo nun. So, kaya kadalasan, pag residential construction, inuuna ng buhusan yung yung beam natin. Although pangit siyang tignan kasi hindi nagiging optimize yung yung construction o yung capacity ng beam natin. But wala tayong magagawa kasi limited lang yung equipment for pag-small construction. But for monolithic construction, mga ready-mix concrete na available na ngayon, okay? So any volume, okay, kaya supply ng mga ready-mix concrete natin. So hanggang hanggang parang yung isang project namin, inabot siya ng 1,400 cubic meter. So kaya namin buhusan yun in 2 days na continuous pouring, 1,400 cubic meter. So imagine ilang truck yun, napakadami. Okay, continuous pa rin yung buhos niya. Okay. Or pwede mo siyang pwede mo siyang i-clear yung buhos niya. Simultaneous yung yung pouring mo sa isang sa slab. So marami kang pumpcrete, marami kang mixer, yung medyo magastos. Okay. So as per code recommendation, the effective plans width, for T-beam, the effective plans width is minimum between these three formula. So number 1, span L/4. So yung span natin, yun yung total span nung beam natin. Halimbawa, meron tayong typical flooring, okay? So yung typical framing plan natin. So if you are going to consider this beam, ito yung span length niya. Ito yung L. So this span length is the clear distance. Okay, kunyari, lagyan natin ng para realistic siya. Okay. So yung framing plan natin, simple na structure lang. Ito yung framing plan natin. Okay. So this span length, if we are going to consider this middle beam, ito yung span length niya. So the clear distance between edges of the framing beams, ito yung L. So for T-beam, span L/4. So BW, okay, so BW plus 8 times slab thickness. So 8 times slab thickness, or just simply BW plus 16 PF. So 8 times slab thickness on both overhang. Okay, so 16 times slab thickness plus BW. Okay, or center to center spacing between webs. So center, ito yung web, ito yung tawag natin na web. Okay, ito yung web. So center to center between web. Okay. So number 3 requirement is center to center. Ito yan. Center to center spacing between web. Okay. So whichever is the smaller, okay, yun yung ngayon yung governing value ng plans o BF. So for edge beam, so ito yung mga case ng ito, for edge beam, the effective plans width is 1/12 of the span, or L/12. Okay. 6 times thickness nung slab. Okay. 6 times the slab thickness. Ito yung overhang na to. Or center to center spacing between webs. So same true with this one. So center to center spacing between webs. So kunyari ito is C. So 1/2 nun, center to center spacing. So yung tributary, ibig sabihin yung tributary nung beam. Okay. So there are cases also na yung center to center spacing niya is different. Kunyari, this is C1, this is C2, So if you're going to determine the center-to-center spacing, instead of C, so the center-to-center spacing is equal to C1 plus C2 over 2. Ibig sabihin, average ng tributary between sides ng flanges. Okay. So whichever is the smaller for L-type, yun yung effective flange with na BF. Okay? So other types of regular beam. So ito yung mga box type section. Ito, yung mga box type. But this one is very seldom natin makita sa construction. So kadalasan sa gutter nagagamit namin to, pero bibihira ka sa gutter. More o ginagamit natin is yung yung U-type. So bihira to. But there are cases na ginagamit din yung box type. Okay? Kasi ito napakahirap formahan. So para formahan mo to, yung void form mo, either gagawa ka ng forma sa loob na hindi na pwedeng tanggalin, or pwedeng styrofoam, yung highly grade na styrofoam, yung high density na styrofoam, pero permanent na siya dun sa loob ng beam. Okay? So kadalasan ginagamit lang itong box type pag gusto nating pag-ano yung structure natin. Halimbawa, di ba yung sa concrete asa natin, sa steel natin, dito yung steel reinforcement natin. Okay? So, halimbawa, yung centroid mo, ito. Okay? So, itong part na to, nung beam, sa below the neutral axis, is wala naman siyang use sa capacity calculation. Kasi ini-ignore lang natin yan. So instead of using the full section, at makabawas ka. Itong section to mababawas mo dun sa bigat ng structure natin. So kaya ginagamit yung either box type. So another is inverted T. Okay? So itong inverted T, makikita ninyo to kadalasan sa mga precast construction or sa mga bridges. Kaya lang sa bridges naman, inverted T siya in the sense na malaking inverted T niya. So ito yung mga girder natin, yung another ASTO girder. Then for inverted U or channel, sometimes they call it as channel section or hollow core. Okay? So same din yung principle ng hollow core sa box type. So minsan yung neutral axis natin nandito. Okay? So hindi mo na kailangan sa, di ba, kung ito yung tension reinforcement natin. So yung part na to is not giving, theoretically, hindi natin kinukonsider sa moment capacity. Kaya lagi tayo dito ng void. So yung void na to is either using PVC or using, may mga prefabricated na, na mga corrugated pipes na ginagamit. Kaya lang hindi na rin siya marirecover. So pag buhos mo siya, naka-embed na yung forma niya sa loob. So, pwede yung styrofoam sa MRT3, yung mga slab doon sa EDSA, ginamitan namin ng boarded slab using styrofoam. So para gumang yung structure namin, naggamit kami ng boarded slab. So ito, double T. So another section. Okay. So kadalasan ginagamit naman to sa mga pedestrian. Okay, makita kayo minsan, di ba, merong, kung ito yung beam o bridge, tapos ito yung mga double T nandito. So, series of double T para maging slab. Okay? So, similar to double reinforced and singly reinforced. So, the idea in determining for the moment capacity of any regular section or T-beam is, again, kukunin mo ulit yung centroid. So you need to locate the centroid of the section. So first is you convert this rebar into equivalent concrete section, which is equal to N times AS. Okay. So ang mahirap lang sa T-beam, there are two possibilities. So it may be that the centroid will be located, or the neutral axis will be located on the plans, okay, on the web, or pwede rin exactly at the junction. But this third, okay, that the third possibility is very seldom, bihira mangyari yon. Okay? So either at the web or at the plans. Kaya magiging dalawa yung analysis natin dito. First is assume that the centroid is located within the plan section. So ngayon, sa track section mo, i-assume mo na ito ngayon yung compression part mo lang. Okay? So ito yung KD. Or just simply X. Okay? Then ito yung NAS mo. So, solving mo ngayon, if makikita mo naman pag nag-negative yung value ng X mo, ibig sabihin, yung centroid mo, mag-locate dito. Okay? Ang pinaka-the best to solve this problem is you assume that the neutral axis is located exactly at the junction between the plans and the web. Diba, meron tayong kailangan, diba, para makuha tayo centroid, moment of area above is equal to the moment of area below. Okay. So let's say we assume that the centroid is this one. So mamakuha mo yung if the moment of area above, so M above, okay, is greater than M below. So meaning, yung neutral axis mo, mas malaki yung moment ng area mo above, yung neutral axis mo is within the plans. Okay? But if your moment above is less than your moment below, so ibig sabihin, yung area ng plans kulang pa. Okay? Para dun sa moment dun sa below. So ibig sabihin, yung centroid mo is within the plans. So ito is within the web pala. Ito yung centroid mo is within the plans. Ito yung centroid mo is within the web. So para hindi kayo mahirapan sa sa analysis kasi makakuha kayo dito by quadratic equation maging negative siya. So kala niyo error na. So mag-test muna kayo, mag-assume kayo na yung centroid nyo is at the junction. Then i-test nyo to. If moment above is greater than moment below, so the centroid is within the flanges. Okay. So you can solve for KD using quadratic equation. But if your moment above is less than your moment below, the centroid is located within the web. So ngayon, mag-assume ka ng value ng X. Okay? Kaya lang medyo complicated siya kasi hindi na siya rectangle, magiging dalawa na yung value mo. So either pag T-beam, pwede mo siyang i-cut. Okay? So pwede mo siyang i-cut into several triangles. So dalawang triangle, this triangle plus this triangle, dalawang triangle. So normally given naman to, so i-assume na ito ngayon yung value mo ng X. So by quadratic equation, you are now solve for your X. Pero pag nag-pulse siya within the plan, so parang nagdi-dissect ka lang ng rectangular section. So after determining for the location of the neutral axis, you can now solve for the centroidal moment of inertia. So after solving for centroidal moment of inertia, okay, makukuha mo na ngayon yung FC saka Fs o yung moment capacity ng concrete saka moment capacity ng steel. So stress is equal to MC over I from the basic formula. If you are going to determine for stress, ito yung formula mo. You're going to determine for moment. So stress is always given Fs, either Fs or Fc. So Fc is 0.45 of F prime C. So this F prime is either 140 for grade 60 or 170 for grade 60 bakal. So ito grade 40. So from that, parehas lang yung analysis, either singly reinforced, doubly reinforced, irregular shape or T-beam. Okay? Kaya lang sa rectangular beam, pero tayong direct formula. But this one, transform mo lang siya sa equivalent area of property. So yung transform section is applicable for all types of beam, either doubly, singly, or irregular section. But there are also cases na yung T-beam natin is also doubly reinforced kasi yung beam talaga natin, meron din siyang compression sa ibabaw. So aside from compression bars, okay, meron ka pang T-beam. So i-convert mo lang siya again into equivalent concrete. Okay? So parang doubly reinforced lang siya. Doubly reinforced na medyo mahirap siya kasi pag nag-fall siya within the plans o within the plans wala problema. Pag nag-fall siya within the web, yun na, medyo mahaba na yung equation na gagawin. Although, madali naman kasi meron kayong programmable calculator, kaya lang medyo nakakalito siya dahil meron na siyang, kumbaga meron siyang puwang in between nung pagkuha nung centroid location nung transform section. Okay? So that's all for working stress design. So for the next meeting will be your first quiz. So your first quiz, I'll be giving you 3 problems. So 1 for singly reinforced rectangular beam, 1 for doubly reinforced rectangular beam, and 1 for irregular beam. So the irregular beam, either T-beam or shapes. Okay, so other shapes like this one. O pwedeng ganito. Okay? So for your exercise, so you can solve this. Okay? So with given values, so assume that F prime C is 28 megapascal and Fy of, let's say, 60 megapascal or grade 60. Mali pa to. 60 KSI. Okay, grade 60. Grade 60 or 60 KSI. So this is equivalent to 170 megapascal yung Fs. Okay, so for your exam, okay, so magbibigay ako ng time. So ubusin natin yung 3 hours para kasi first exam naman. So this is just giveaway exam. So we use 3 hours for the 3 problems para naman yung first quiz niyo mahaba na yung meron na kayong ma-perfect yun na. So meron na kayong advantage para sa mga susunod exam. Okay, kasi ito yung pinakamadaling exam. Yung ultimate stress design medyo tricky na yun kasi hindi na pwede yung transform section. Okay? So ito parang parang review nyo lang to dun sa mechanics, strength of materials ninyo. Okay? Diba yung last part ng strength of materials, meron dong concrete. Parang working stress din yun. Kaya lang, medyo unrealistic yung mga value at mga stresses na binibigay. Okay? So that's all for tonight. So any questions? Verifications?
Question po.
Yes?
Sir, for our assignment kanina po,
Yes?
okay lang po bang mag-request po regarding sa deadline to extend kahit this week lang po? Kung okay lang po sana. Since
Ano yun?
meron naman po plus point. Yung sa assignment po kanina. Sir.
Okay. Sige. Okay lang. So, Sige.
Okay lang po hanggang.
Okay lang, okay lang. Siguro baka nagugutom na kayo, masyadong magayan natin. 3 hours.
Opo.
Kahit ako, gutom na rin eh. Okay, sige. O sige,
Thank you
paano?
po, sir.
Wala siyang deadline within this week. Okay? Basta kung sino yung first 5, so yung may mga plus points. Okay? But kung
Thank you po, sir.
ipipitin, pag gutom na kayo, ubayan nyo yung plus points. Kumain muna kayo. Okay? But if you can, you can solve, mas maganda para meron na kayo advantage. Ma-perfect nyo yung first quiz, 100, tapos meron kayong 20, may 120 na kayo. So, ibig sabihin, sa exam ko kasi, meron ako laging plus 20. Okay? So, pag meron kayong plus 20, nasabit yung assignment nyo, tapos plus 20 sa exam, tapos naka 80 kayo, meron na kayong 120. So, ibig sabihin, halos tatlong quiz na yung kaya nyo i-cover nun na 40. Okay? But of course, yung natin, yung passing natin lagi is 50% ba yung passing? 50% yata yung nasabi ko nung una. Okay? Okay, so by the way, sa exam pala, so magpo-post ako ng dun sa Google Classroom. Tapos ang gagawin ninyo is solve nyo lang yung exam in any paper, pero i-picture nyo siya, then i-send nyo siya, i-upload nyo siya sa Google Classroom used by PDF. So you can picture this by your cellphone, then convert it sa PDF, and then upload dun sa Google Classroom. So yung deadline, halimbawa 6 to 9 yung exam natin, 6-9 p.m. So dapat on or before 9 p.m., nasubmit nyo na lahat. Otherwise, every minute of late equivalent to deduction of 10 points. So, halimbawa, nasubmit mo siya 10 minutes late. O 0 ka na, wala ka ng points. Okay? So, mahaba naman yung mahaba yung 3 hours for the 3 problems. You can solve the one problem, especially for investigation, in less than 30 minutes. Ang medyo mahaba lang yung design problem kasi di-design mo siya. After designing, i-arrange mo pa yung bakal. After arranging ng bulb, kukunin pa yung moment capacity. So swerte mo pag tama na yung design mo na yung moment capacity niya is greater than your actual moment. Pero pag kulang siya, like yung nangyari kanina, okay, babalik ka ulit. Magdadagdag ka ng another bakal. So, another investigation na naman ulit. So, kung kulang pa rin yung assumption mo, dadagdag ka na naman. So, medyo mahaba yung design. But in investigation, maiksi lang siya 30 minutes. So, yung T-beam o yung regular beam sa single reinforced rectangular beam, you can do it in 1 hour. So, meron ka another 1 hour, another 2 hours for design of double reinforced rectangular beam. Okay? Some more questions?
Sir, question po ulit, sir. Yung first 5 po ba na plus point po, sir, is per section po or sa amin na pong 3 section?
Yeah, for 3 sections na yan.
Okay po, sir.
Okay.
Thank you po.
So, binibigay ko yung exam at exactly 6 p.m. Okay? So, pwede kayong mag-log in na mas maaga. I-open ko naman na yon. Tapos, by the way pala, during the exam, kailangan naka-open yung camera. But of course, there are cases na medyo mahina internet connection. Hindi ko rin ma-view kayo. So, pwedeng ma-weave yung open camera. Pero pag kaya mong i-open, pag sabi ko open camera, i-open yung camera nyo during the exam. Okay? So, pag naka-open camera kayo, meron kayong plus 20. Pero pag na-close yung camera nyo, okay, may minus 50. So, kailangan ma-perfect ninyo pag naka-close camera kayo para pumasa kayo. Okay? So, I suggest na sana during the exam, maging honest lang kayo. Okay, honest lang kayo para as training na rin yun para sa pagtrabaho kayo, at least honest kayo. So hindi nyo dadayain yung mga materyales. Ngayon pa daw pasanay na kayo sa honesty. Although ngayon maraming contractors na talagang rampant yung yung sa construction ngayon. Kahit sa mga project namin, itinatago ng mga contractor yung kung ano yung tingin nila madali sa kanila, yun ang gagawin nila. Pag nahuli ng inspector, repeat. Pag hindi nahuli, wala na. Andun na yun. Okay? Lalo na sa roadworks, napakadaming pandayang ginagawa ng mga contractors. Okay? Kasi iba nagda-dive masyado sa sa bidding, tapos dadayain yung materyales. I hope sana pag naging kayo, nagtrabaho kayo, wag na wag yung gagawin yun. Okay? Kaya nga dapat yung contractors dapat mga CE Kasi ngayon marami ng contractor na hindi naman talaga CE. May mga puhunan lang, naging contractor, nakukuha ng CE. So parang nangyayari ngayon, nagiging utusan tayo ng mga kapitalista. Okay? Pero dapat sa inyo, pag nagka-graduate nyo, wag na kayo, pumasok kayo. Pero ang pinaka-aim nyo palagi dapat, wag kayong titigil na masukan lang kayo. At least may goal kayo na kayo yung owner ng company, kayo yung owner ng construction. In the same way, hindi lang maganda para sa inyo, but in our country, pag yung civil engineers ang contractor, sigurado tayo na hindi natin dadayain yung mga projects. Okay? Kaya minsan, di ba, ang dami na bumagsak yung tulay, bumagsak yung nag-crack yung kalsada, especially sa EDSA. Parang weekly merong repair. Pero tingin ko problem yun sa quality control. Hindi kasi yung concrete, di ba, ang warranty ng construction is 1 year lang. In 1 year time, di mo nakikita yung damage ng konkreto. For long more than 1 year. Kaya maraming contractor talaga nandadaya kasi alam nila in first year na warranty period nilalabas yung mga defects in structure. After several years saka lumalabas lang. Okay? Any questions? So that's our call tonight. Kung meron pa kayong questions, okay? Kung may questions kayo, either sa Google Classroom, you can post question or sa Messenger. Mas maganda sa Messenger para nabasa ko. Sasagutin ko 'yun kung meron kayong mga clarifications. Okay?
Sir, pwede pa send ng code sa Google Classroom. Di pa po kasi ako naka-join.
Hindi ka pa? Pero may i-send mo sa akin yung email mo?
Pwede dito na lang po, i-chat ko po.
Sige. Chat mo sa akin yung email mo. Sige.
Sige po.
Okay, so exam, exactly 6 p.m. Doon na yung exam, pwede kayo mag-start ng
Sir, na-chat ko na po.
Okay, sige. Sige,
Thank you po.
sa classroom.
Thank you.
Sir, question po.
Yes.
About po dun sa assignment po. Kahit hindi po kami pasok sa top first 5 po sa pagpasa po, need pa rin po namin magpasa.
Hindi na. Pag kunyari, meron nang napagpasa na first 5, ang lang doon, tama ba yung first 5? Okay. So, pag may chances kayo, pag mali yung first 5.
Sige po, sir. Thank you po, sir.
Sir, wala po bang additional po kapag nag-try?
Walang additional pag paano yan? Paano? Pag more than 5 na. Okay. So, gawin natin first 20. First 20, kasi lakihan natin para medyo maganda yung yung score niya sa first exam. Yung first 20, meron kayong 20 points. Okay, yung 21, ilan ba kayo? 100, no? So 21 to 40, meron kayong 15 points. Okay? Yung 41 to 60, meron kayong 10 points. So yung 61 and above, so meron kayong 5 points. So para lahat kayo meron points. Okay? Okay, meron pa kayong questions? So lahat kayo magpasa na para kayo at least meron kayong meron kayong ano ba yun? 5 points ba? Meron kayong 5 points. Okay, lahat magkakaroon ng 5 points. Yung sa 61 pataas. Okay? So meron pang questions? Okay, so kung wala ng questions, see you next meeting for your first quiz. Okay, good night everybody and keep safe everyone. Thank you.
Thank you po, sir. Good evening po.
Thank you po, sir.
Thank you, sir. Keep safe.
Thank you po.